Okay, we're going to do a quick look at how to use StreamStats by the USGS today to get some flow data for either ungaged basins or parts of drainage basins that are in between stream gauges, where we don't have kind of direct measurements of flow. So on the StreamStats webpage, this is a web-based tool to do all of the work that you need to do here. And the key kind of navigation features are the layers menu up here in the upper right, where you can choose from a series of different base maps. So things like the default here is the National Geographic base map. You can switch to a purely topographic map. Imagery could be useful depending on how you're trying to find your basins or trying to look at some of the basin characteristics. You can also do a shaded relief. This looks at kind of elevation and topography as well. We're going to stick with the National Geographic map for this demonstration, but you can definitely switch between these at any time. So for the different steps, you'll definitely see different layers pop in and out in this layers menu. And you can open up the little submenus to see the legends for those different layers. The other important navigation tool is down here in the lower left. This has got your kind of latitude and longitude, the map scale, but more importantly, in StreamStats, they use something called zoom level. So this is kind of the different steps that you can zoom in and out to. And there are certain parts of the process where you'll need to be at a certain zoom level. So if it says to be zoomed in to like level 11 or level 15, in the different steps, that's where you'll find the zoom level is down here in the lower left. So the first thing that you'll want to do is kind of decide where you need to get your data. I'm going to zoom in to central Colorado and pick a small basin that comes out of Rocky Mountain National Park. So as we zoom in, okay, I'm just using my mouse wheel to zoom in. You can use the plus and minus keys here on the page. As you zoom in, you'll see different layers pop up. And so right now you can see these gray outlines have popped up. These are different watersheds. And if we zoom in one more level, you'll start to actually see the USGS stream gauges that they have data for and that are used as part of this process. So if we zoom in a little bit more, I'm going to go find a small stream up here. Right here at Glen Haven. This is what's called the North Fork of the Big Thompson River, comes down through here. And right at Glen Haven is where we will try to get our measurement. So the North Fork of the Big Thompson River comes in right here and travels up into Rocky Mountain National Park and up into the high mountains just up here. So we're going to zoom in to about where we want to put the bottom of our watershed, so where we actually want to get the flow statistics. And depending on the size of your watershed and where you've chosen, you should hopefully only see one state over here in the state or region. If you've selected a bigger watershed or a watershed that spans 2 states, you may see multiple states, and you want to pick the one where the majority of the river basin is located. So in this case, I'm just going to pick Colorado, so click on that. And then the next stage is to delineate the stream basin. So we're actually going to click on this tool. And once we do that, you'll see that these blue flow lines pop up. Okay? And these are where we can actually take, or we want to actually sample the river that we're interested in to get the measurements. So in my case, the North Fork of the Big Thompson comes in from the north here. And I want to take a measurement right before we get to Glen Haven. And so what you're going to do is put your crosshairs right over one of the blue cells of the streamlines that are here. And you'll click, and that'll put a point there. Okay. It'll say that your clicked point is valid, and then it'll go off to actually delineate the watershed that's above this point. So all of the area that would drain to this point in the stream. If you pick a spot that's off of a stream, it will still try to delineate a watershed, but it's not likely going to be very useful for you. So do try to get it right on one of these blue lines. Okay, so there it's delineated our watershed, and so it's highlighted there in yellow. Now at this point, you could zoom in and make edits to this stream basin if you were so inclined. Generally, the basin that's output is correct, so you don't generally have to edit anything, and usually I just leave it alone. And so if that looks good to you, which it should hopefully because you clicked the right spot, you can go ahead and say continue. And now it's going to go through, based on your state or the region that you're in, it's going to actually kind of pull together all of the different called the regional regression equations and regional regression parameters that it can use to calculate the flow in this ungaged basin. So this generally takes a minute or two. Okay, and once that's finished, okay, it'll move down to this next tab on the left-hand sidebar here to say select scenarios. So in this case, you're going to want to select scenarios, and generally the ones that we're most interested in are the peak flows. So this is going to calculate some flood frequency statistics for us. The low flow statistics is kind of the average low flows that we'd expect in this basin. And then the flow duration statistics are kind of our average daily flows that we'd expect statistically in this basin as well. You can do these other statistics, so flood volume statistic, annual flow, monthly flow, bank full. Those will give you interesting results, but generally what we're interested in most cases are the peak flow, low flow, and flow duration, just because those are kind of our key hydrology statistics. So the next thing that you'll want to do is come down to the Basin Characteristics submenu here. And if you open that up, this gives you a list of the basin characteristics that are available for this specific basin. Now, the ones that are checked in here are the ones that are needed to run these different scenarios. So the peak flow, low flow, and flow duration. If you add in other of these scenarios, you will get more or less basin characteristics. But there are some in here that you might want to add in. You can look through these and add in ones you think might be helpful, but the ones that are checked are the ones that are absolutely necessary. And so once you're happy with that, you can say continue. And so down here in the lower right, you can see that it's calculating the basin characteristics. And when it's done with that, it will give you an option to build up the report. Okay. And depending on how big your watershed or your basin is, these different parts of the process here will take different amounts of time. If it's bigger, it'll take longer. If it's smaller, it'll take less time. So here you can show basin characteristics. There's a little menu right here. Okay, and so you can see some of the basin characteristics it's using. So the drainage area here is 18.5 square miles. Precipitation amount, elevation. So you can just use these to kind of check the values that you might need or that have been produced. And then once you're, if you've got too big of a drainage area, you could go back to the beginning and start over. But if you're happy with all of that, you can click on the bottom button here to continue to get our reports for the basin characteristics and the flow reports. So say continue, we'll get this report pops up. Okay, and so the first thing that you'll want to do at the top here for your report title is go ahead and type in something meaningful. So this is the North Fork of the Big Thompson. And then usually we do the name of the river and then generally at a location if it's near a location. So in this case, we'll say near Glen Haven. Okay. And if you want to enter in some comments about why you chose this site or what you think what you think the site characteristics should be for later comparison, you can put in comments here. Those are optional. But as you go down, you'll see that we have the basin outlined here. You can, if you click on the layers tab up here, you could change this to an imagery background or a topographic background or a shaded relief background if you want. Okay, it's up to you as what you want to display. I'm actually going to go for the imagery. And then the next part down here are the basin characteristics that we saw on the sidebar there, but these pop out so that we can have them as part of a report. And then the next series of kind of panels in the report here are the different scenarios that we chose. So here is the peak flow statistics. And so these are the parameters that it used to calculate the peak flow. And then the different statistics here are the different exceedance probabilities that we've talked about in class. So the 50% flood is the 2-year flood, all the way up to the 0.2% flood, which is the 500-year flood. And so for this basin, since it's a relatively small, high-altitude basin, the 2-year flood is about 150 cubic feet per second versus the 500-year flood is about 550 cubic feet per second. The next panel is the low flow statistics. And so again, this is the parameters that it used to calculate these. And then the different statistics here are the 7-day, 2-year low flow. And these will be different depending on the state and depending on the region, how these are calculated. But generally, you'll see something like this. But so the 2-year low flow is, again, kind of the average low flow. 10-year low flow is will always kind of be a little bit lower, and the 50-year flow will usually be lower than that. And so these, again, are kind of some based on kind of exceedance probabilities, how often we should expect low flows of these different values. So 2-year low flow is something we should expect fairly often, versus the 50-year low flow should be something that would be relatively infrequent. And then the last panel here is the flow duration parameters, or flow duration statistics. And so again, these are kind of based on kind of daily exceedance probabilities. So how much water would we expect on any given day in the river? And so things like the 90% duration, okay, is going to happen a lot. Okay, so that's a fairly low flow in this case. The 50%, so if we went out to the river at any given time, 50% of the time we'd see something kind of higher than about 5 cubic feet per second. And then something like the 10% is those are fairly high, those are the higher flows, and so we wouldn't see flows that high very often. So those are the different panels. One thing to note is that if your basin does kind of span different regions, you will see potentially multiple peak flow or multiple low flow or multiple flow duration statistics. And the thing to keep in mind if you see peak flow, if you see like 2 peak flow panels, is that they could be in different parts of different regions, depending on where your watershed is. And so the key thing to look at in those different panels is it'll say how much of the watershed is within a certain region. So in this case, I have 99.5% of my 18.4 square mile basin is within the mountain region peak flow. And if you have a basin that's split between different regions, that percentage, this first percentage will change. And so usually you'll use the one that has the highest percentage. So if you have one that's like 85 and 15, or one panel that's 85% and one panel that's 15%, use the one that has the 85%. That's a majority of the basin. So the last thing that you'll want to do with this report is download it. So there's 2 ways to download. The first is to download it as a CSV file. So if you download the CSV file, Okay, this will download as a table that you can open up in Excel. And then the other thing that you'll want to do is print the report as a PDF. So use your browser's print function to print the entire report as a PDF so that you can save it. That'll include the map, that'll include all the tables, everything, so that you have a PDF of this. One thing to note is if you do hit print on this and use your browser's print function, sometimes it will take a while to generate the PDF. So just if you hit print and your browser kind of goes gray that it's thinking too hard, just leave it be, and it should come back to life once it's generated the PDF. So go ahead and so download it as a CSV file and then print it as a PDF. So once you're done with that, you can close the report, okay? And then if you want to do another stream gauge, okay, you can actually just reload the page and it'll blank everything out and you can start over again. And then once you're ready to do some comparisons, you can actually go find your the data that you downloaded, okay, and it'll usually have just a generic name. So the first thing that you'll want to do is probably rename this so that you can actually find it later on. So this is North Fork, Big Thompson, at Glenhaven. Okay. And so if you want to open this up as an Excel file, most computers should kind of associate a CSV file with Excel. So if it's not associated with Excel directly through the icon, you can open up Excel directly and just use the open dialog to open up the file, navigate to that file and just open it directly. Okay, and you may have to change the file types here. Usually I just do all files. And you can scroll down in your folder here to find the file. There it is. Okay, so we'll open that. And so you can see here, this is the output report. Okay, and so you have several different tables kind of stacked on top of each other. So here's the kind of latitude and longitude and the time at which you did it. Okay, here are the core basin parameters we chose, the peak flow statistics with the flood frequencies, low flow statistics, and then the flow duration statistics down here at the bottom. So that's how you get all of these data into Excel. And that should be a good place to start your analysis after you've gotten these data out.